3, if you remember, level 3 was on EC BLD, right? So on your notes, be sure that you have the following. The EC stands for the electron configuration. It is the placement of the electrons in shells and sublevels. This is what we came up with yesterday when I was teaching this. It is the written map of the directions. So think about MapQuest, right? Or Google Maps. When you have Google Maps, you have not only a map that has a physical drawing on it, but you also have the written directions, right? Where it says, take exit this, turn here, right? Written directions. The electron configuration is the written directions, okay, for the map. Think of it also as a seating chart. It is where everybody has to sit. So this is the seating chart for your class. It's got all your pictures on it, and it's a physical location of where everybody is. But I could also have a written map that says Kinsey is in seat 1 of table 1 and the yellow section. Okay? Does that make sense? Okay. So the shells all hold individual electrons in sublevels. And you should already have this in your notes. But shell 1 holds 2 in the S section, 2 holds 8 in S and P, 3 holds 18 in S, P, and D, 4 holds 32 in S, P, D, and F. And there are 2 ways to do the electron configuration. One I call EC math, right? The electron configuration math. Going to show you that again. It's where you use the chart on the back of your periodic table. Right here, use the chart on the back, and you literally write down where everybody is going to sit. Okay? The other is called fill the funnel, and it is using the periodic table itself, as if you were pouring the electrons in and one's going to get caught in every spot on the way to your destination, if you will. Okay? So we're going to do another one of those together. But that's the electron configuration. After that, things got easier, if you remember. The Bohr model is the picture of the particles in location. And on the back, you have a template of what that will look like. And you just draw what you need. You don't have to draw the whole template. Okay, you just draw what you need. The L stands for a loop diagram. It's a squished Bohr model, right? And it shows the total particles. It looks kind of like a sound wave or a Wi-Fi signal, right? And then finally you have the dot diagram. It shows the symbol with its valence in little groups of 2. This is what you have to do on your assignment today. And you have, I think, either 5 or 6 problems that you're going to do. So write this down in your notes. This is a full example of the entire acronym, NPNEIAISECBLD. Okay? So these are 12-step problems. So we're going to pick something easy in the beginning. So we're going to do F 919. Okay? Write it down, please. Write it down. F9199, right? This one is easy because it is, that's the other thing. Okay, this one is easy because it goes, it's above the gap. And I'm going to show you what happens in the gap in a second. This is above the gap. So, name, fluorine, right? There are 9 protons, 10 neutrons, and 9 electrons. By this point, this should be almost automatic. You should be able to look at that ion notation and go, okay, I know there's no charge, so protons and electrons are the same, and I know to take the top minus the bottom, okay, to get neutrons. This should be almost automatic. Is it an ion?
No.
No, it is not an ion because there's no charge. What is the AAM directly from the periodic table for fluorine? Your periodic table. 18.99. So remember the isotope question, and this is where everybody was like, what? The isotope question is this value rounded different than this value given? No. And that's your answer to your isotope question. I'm going to say that again. Is this, and you have to watch because when I say it, it doesn't make any sense, right? Is this value, the AAM, rounded, okay, hold that number in your head, different than the AM that was given? No, they're the same number.
So the rounded number, is the rounded number the same as?
Is the rounded number here, this, no, you gotta say the word different because you're answering your own question. And that's your answer to your isotope question. If they are different, then you have an isotope. If they're not different, if they're the same, you do not have an isotope. And it's backwards. So that's why you have to say, are they different? And you have to answer that question. Okay, otherwise it gets really confusing. So remember the two I questions. Is there a charge? That one's easy. And then this one is this value rounded different than this value given? No. If they were different, you would say yes, and you would write down yes. Is it stable then? Yes, because it is not anything else. It's not an ion, it's not an isotope. Okay? Then we're going to come out here and do the EC math. Okay? Because this is now level 3. EC math goes like this. It uses this chart on the back. Okay?
Oh, yeah.
As if you had to position everyone in their spot. And you're writing written directions to give to somebody. Okay? Instead of drawing a map, you're writing written directions. And the EC math is the way to get the EC, not the actual answer itself. That's why it's off to the side. Okay? So, I have 9 electrons to start with. Right? According to the chart, I start with 1s. I take them to 1s and 2 people are able to sit down. Now I have 7. I go to 2s, following the arrows on the chart. 2 people could sit down because the S section only holds 2. Now I have 5 people. I take them to 2p. 2p will hold 6 people, or electrons, but I only need 5 spots. Okay? And the answer to the electron configuration is hidden inside the math. It is the 1s2, 2s2, 2p5. It's inside the math. That's the electron configuration. And again, you have to do 5 problems on your own today. So, then the Bohr model, and you use your template, again, on the back of your periodic table, puts 9 protons and 10 neutrons in the nucleus. Remember that when you do the electron configuration, right, and we look at 1s2, this first one is the shell number. The S is the sub-level. And the last two is the number of occupied seats. Okay? That's the format of the electron configuration. The shell number, the sublevel, the number of occupied seats. Okay? So, I only need 2 shells. In the S section, again, following my template, the S section would be here, and I can put X's, slashes, E's, whatever makes the most sense to you. You can put dots and color them in. But I have 2 on S1, 2S2, and 2P5. I follow my written directions to draw my map. Shell 1, section S, 2 seats. Shell 2, section S, 2 seats. Shell 2, section P, 5 seats. Okay? The loop diagram is the squished Bohr model. The loop diagram is the squished Bohr model. And it puts the protons and the neutrons in the nucleus. I only need 2 shells. And it shows me the total on each shell. So shell 1 only has 2 on it. And shell 2 has 7 on it. That's the loop diagram. The dot diagram shows the symbol with its valence as dots in groups of 2. So remember, on the periodic table, we wrote the valence and we circled it. So you find your element, you go straight up. The valence number is circled up there, so it's 7. And remember, they have to go in little groups of 2. So you have 7 for fluorine. 7 for fluorine. Now, could they be rearranged slightly? Yes. But remember, they need to go around in little groups of 2.